I hope I'm audible to all students who are attending this lecture of statistical methods for economics. In this particular lecture, I intend to start with a very important module in my statistical methods for economics course. This is elementary probability theory. So all students attending this lecture can write down elementary probability theory. It is one of the very important modules I cover up in my statistical methods for economics course. The books I prefer to follow as reference for my lectures on this module. This is Probability for Statistics and Engineers by J.L. Devore. Another book I prefer to follow for practice on this particular module, Fundamentals of Statistics by S.C. Gupta. And along with this, I also prefer to follow Statistics for Business and Economics by Alan Webster. So I have written down the name of the authors. These books are quite easily available, okay, online as well. And I prefer to follow these three books for my lectures in elementary probability theory. Okay, now before jumping into probability, probability is something which students must have done even at the high school level math or statistics course. Okay, before understanding the concept of probability, we are first of all going to look at some important terminologies. Okay, so let's write the first so I am writing important terminologies. Some important terminology. Okay. So first one, let's understand what is meant by a sample space. Before that, let's first of all understand what is meant by an experiment. Let's understand what is meant by an experiment. So we can write an experiment. An experiment is any activity or process whose outcome is subject to uncertainty. Whose outcome is subject to uncertainty. So when we talk about an experiment in statistics, when you are conducting an experiment, you don't know exactly which outcome will take place. So the outcomes of an experiment are uncertain. For example, a very simple experiment of tossing a coin. Now you don't know with certainty whether heads will come up or tails will come up. The outcome is uncertain. You can list the outcomes of an experiment, but you can't say with surety which outcome will happen. That is why it's an experiment. When you are experimenting with an activity, you have in your mind the list of all possible outcomes which can occur, but you don't know with surety which outcome will occur. Okay, now let's understand what is meant by a sample space. So here comes the next terminology, sample space. So I can write the sample space of an experiment. The sample space of an experiment denoted by delta. This is the symbol I use, for denoting the sample space. If students are following a different book, the symbol might be different, but symbols don't matter. What matters is the concept. Okay, the sample space of an experiment denoted by delta is the set of all the possible outcomes, of that experiment. So when you list all the possible outcomes of an experiment in a set, it's called a sample space. Okay, so let's take an example, let's take a numerical example where we look at the experiment and we write down the sample space. So for example, let's look at example 1. Consider an experiment. Consider an experiment of examining a single fuse to see whether it is defective or not defective. Okay, so let us consider an experiment where you examine a single fuse to see whether it's defective or not defective. What is the sample space? So I can write, therefore the sample space of this experiment, is given by delta, which is consisting of, there are two possibilities. You are just checking one single fuse. That single fuse can be defective, or another possibility is it's not defective. So the sample space of this experiment is D, ND. So it has how many outcomes? In total, it has 2 outcomes. Let me erase the initial part and let's look at another example. So I'm erasing the initial part off from the screen, and we are now looking at another example where we are going to write down the sample space of the experiment. So erasing this initial part off, I can now write, let's consider example 2. Consider an experiment. Consider an experiment of examining 2 fuses to see whether they are defective or not defective. So now, instead of one fuse, we are looking at 2 fuses. And we want to check whether they are defective or not defective. What is the sample space? The sample space, I can write, of this experiment. The sample space of this experiment is given by delta, which is, now what is the sample space? The first fuse, one possibility is that both the fuses are defective. Another possibility is the first one is defective, the second one is not defective. Another possibility is the first one is not defective, but the second one is defective. Okay, and another possibility is that the first one is not defective, the second one is also not defective. N denotes not defective, so I'm not using ND, I'm using N. So I'm repeating this example again. We are now looking at an experiment where instead of one fuse, I am now looking at 2 fuses. And we want to check whether they are defective or not defective. D denotes defective, N denotes not defective. The sample space is given by, one possibility is both the fuses are defective. Another possibility is the first one is defective, second one is not defective. Another possibility is first one is not defective, second one is defective. And the last possibility is that both the fuses are not defective. How many outcomes? In total, 4 outcomes. Now, can students observe a pattern? See, how did I get 2 here? This was 2 to the power 1 because there was only one fuse. And 2 to the power 1 is 2. Here I had 2 fuses, so I got 2 to the power 2, which is 4 outcomes. Let's look at the third possibility. Let's look at the third example. So for this, I am erasing this part off. Erasing this part off. Let's now look at the third case. So consider Consider an experiment of examining 3 fuses to see whether they are defective, to see whether they are defective or not defective. Again, D denotes defective, N denotes not defective. So I can now write that the sample space of this experiment, the sample space of this experiment is given by how many elements will it contain? How many outcomes should it contain? There are 3 fuses. So it should contain, ideally, it should contain 2 to the power 3, which is 8 outcomes. Let's look at all of them. One possibility is all 3 are defective. Another possibility is the first 2 are defective, the last one is not defective. Another possibility is first one is defective, second one is not defective, but the last one is defective. Another possibility is first one is not defective, but the other 2 are defective. Another possibility is that first one is not defective, second one is defective, but third one is not defective. Another possibility is first 2 are not defective, last one is defective. Another possibility is that first one is defective, but second and third are not defective. And the last possibility, all 3 are not defective. Can we count them? 1, 2, 3, 4, 5, 6, 7, 8. You can clearly see it contains 2 to the power 3 because we had 3 fuses, 2 to the power 3, which is 8 outcomes. So I can say that in general, if an experiment has n outcomes, then the number of elements in the sample space are going to be 2 to the power n. So I can erase all this off and I can write a note. If an experiment has n outcomes, let me correct myself. If an experiment has n objects, then the number of elements in the sample space, or outcomes in the sample space will be 2 to the power n. If an experiment consists of n outcomes or n objects, then the number of elements or outcomes in the sample space will be 2 to the power n. Now, a homework problem for all students is that write down the sample space. Write down I can write down the sample space for the following experiments. This is something which all students should take up as homework problem. Write down the sample space for the following experiments. 1 coin is tossed. And I can say 1 fair coin. Fair means it contains 2 outcomes, head and tails. 1 fair coin is tossed. Another experiment is 2 fair coins are tossed. Another possible experiment, 3 fair coins are tossed. And for all these 3, H will denote the heads, T will denote the tails. This is a homework problem for all students. Okay, all students can take this up as homework. Okay, now let us look at what is meant by an event? So I am erasing all this off now, and let's write the next thing, the third. I can say, I can write down the third one, which is event. So we have looked at two definitions. We have looked at the definition of an experiment. We have looked at the definition of a sample space along with practice. We now look at what is meant by an event. So an event is any subset of outcomes contained in an event is any subset of outcomes contained in the sample space delta. Contained in the sample space delta. That means from the sample space, if I take a subset. Now, to understand this, students should have covered up set theory, something which we do in math at the high school level. When I take a subset from a sample, that's called an event. Okay, so I can say that the event lies within the sample space. Sample space contains all possible outcomes. From that, if I take one particular outcome or some of the outcomes, that's called an event. So event is a subset of the outcomes contained in the sample space. I can further write point A, an event is said to be, an event is said to be a simple event. An event is said to be a simple event if it contains exactly one outcome. If it contains exactly one outcome from the sample space. From the sample space. And I can write an event is said to be a compound event. An event is said to be a compound event if it contains more than one outcome from the sample space. If it contains more than one outcome from the sample space delta. Here also I can write delta. Sample space is denoted by delta. So when you take up exactly one outcome from the sample space, it's called a simple event. When you take more than one outcome from the sample space, it's called a compound event. Okay, let's understand this through an example. So before going into the example, I can write a note and then we look at an example. So let's look at a note. In general, exactly one simple event occurs. In general, exactly one simple event occurs, but many compound events occur simultaneously. Many compound events occur simultaneously. That means in reality, only one event will occur. But along with that, multiple or compound events can occur simultaneously. Let's understand this by taking an example. So I am first of all erasing all this off. Let's look at an example. An example to understand. An example to understand simple versus compound events. Let's look at an example to understand simple versus compound events. Okay, so consider an experiment. Consider an experiment in which each of the three vehicles, consider an experiment in which each of the three vehicles taking a particular freeway exit, are, turn either left. They turn either left captured by L or right captured by R. First of all, let's write what's the sample space. There are three vehicles. I can say three objects. How many elements will be there in the sample space? 2 to the power 3, which is 8 outcomes. So I can say the sample space of this experiment is the sample space of this experiment is given by, what's the sample space? Delta. One possibility is that all the three vehicles turn left. Another possibility is the first two vehicles turn left, the second one turns right. Another possibility is first one turns right, first one turns left, second one right, third one left. Another possibility is that first one turns right, the next two turn left. Another possibility is first one turns right, second one left, third one right. Another possibility is RRL, right, right, left. Another possibility is another possibility is that first one turns left, but second and third one turn right. And one last possibility is that all the three vehicles turn right. You can count the number of outcomes: 1, 2, 3, 4, 5, 6, 7, 8. You can clearly see 2 to the power 3, 8 outcomes. There were three objects or three vehicles. The sample space contains 8 outcomes in total. Okay, and now suppose suppose we consider the following event. Suppose we consider the following events. So event A is all three vehicles turn right. All three vehicles turn right. How many outcomes are there? Only one. RRR. This is a simple event. Why is it a simple event? Because it contains only one outcome. It contains only one outcome, RRR, from the sample space, where all three vehicles turn right. And you can clearly see event A is a subset of the sample space. That means if the sample space occurs, A will occur for sure. You can clearly see, I can write in the bracket, A is a subset. This is the symbol we use. A is a subset of the sample space. Okay, let's consider event B. Event B is the event that exactly one vehicle turns right. Exactly one vehicle turns right. Can I write B? So how many cases we have where only one vehicle is turning right? Let me use red color. This case, LLR. This case, LRL. And this case, RLL. These are the only three cases where exactly one of the vehicle turns right. You can clearly see that it's a compound event. It's a compound event. Why? Since it contains more than one outcome. Since it contains more than one outcome from the sample space. And all students can carefully observe that the event B is also a subset of the sample space, which means whatever elements are there in B are also there in the sample space. So I hope all students attending this lecture have understood this. Let's look at another example. So if I erase the initial part off, if I erase this part off, let's look at another example. Where we have the event C. So the event C is that the C is the event that at most one of the vehicles, at most one of the vehicles turn right. Now, can we write the elements of event C? At most one of the vehicle. At most one means none of the vehicle turns right, or exactly one of the vehicle turns right. So in blue color, we can pick this up. At most one of the vehicle turns right means, first of all, no vehicle turns right. That means LLL, all turn left. And another possibility is exactly one of the vehicle turns right. Exactly one vehicle turns right means LLR, LRL, and RL. Okay, so you can again see that it's a compound. This is a compound event since it contains more than one outcome. It contains more than one outcome from the sample space. And all students can see that event A was a simple event since it contains exactly one outcome. It contains exactly one outcome from the sample space. That means, what do we learn? I can say, therefore, A is a simple event, whereas B and C are compound events. Now, suppose this experiment took place and it was observed that all the three vehicles turn left. So I can write, suppose after the experiment, it was actually observed that all three vehicles turned left. That is LLL. LLL occurred. LLL occurred. You can clearly see that let me slightly modify it. Suppose after the experiment, it was actually observed that all the three vehicles turned right. Suppose I take right, not left. It was observed that all three vehicles turned right. That is RRR. Now, this is what actually occurred. You can clearly see that A has occurred. And along with A, you can clearly see that the simple event A has occurred. Okay, and along with A, what all other events have occurred? Suppose I could have taken an event D also. Let's say that the event D was that three vehicles turn in the same direction. Can I write the elements of D? All three vehicles turn in the same direction means either all three go left or all three go right. And students can see that this is also a compound event because it contains more than one outcome. What I'm trying to prove to all students is that when actually all the three vehicles turned right, event A, which is a simple event, occurred. Event D also occurred because event D also contains RRR. So when I made all students write a note that along with the simple event, compound events also occurred simultaneously, you can clearly see that when the experiment actually took place, and suppose it was actually observed that all the three vehicles turned right, both A and D occurred. Both the events A and D occurred because A also contains RRR. A also contains RRR, which is a simple event. D also contains RRR. Because event D was that all three vehicles turn in the same direction. Now all three can go left or all three can go right. And it's a compound event since it contains more than one outcome. So when one simple event occurs, several other compound events also occur simultaneously with that. When event A occurred, event D also occurred simultaneously because both A and D contain RRR. Both A and D contain RRR. So when the event A actually occurred, along with that event D also occurred because D also contains RRR as a possibility. Okay, so I stop now in this particular lecture. The objective of this introductory lecture to probability was to look at the basic terminologies involved in statistics. We have looked at the concept of experiment. We have seen what is meant by a sample space and how do we calculate that. We have looked at what is meant by an event. It's nothing but a subset from the sample space. We have looked at the difference between simple and compound events in this lecture. And we have also learned that when one simple event occurs, many compound events also occur with that simultaneously. Now, in the next lecture of elementary probability theory, we are going to look at relations from set theory. So I am going to revise a bit of set theory in the next lecture. Something which students have covered at the high school math and stat levels. Relations from set theory is something which I'm going to explore in the next lecture. I stop in this lecture. I hope all students have enjoyed this lecture. Any doubts? You can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschooloфeconomics@gmail.com. This is where I stop in this lecture.